question we've been given the parametric equations to find a point on a Talbot's curve. In this Talbot's curve, as t changes, we move around the curve, and we want to know the value of t that we would need to get to the point 1, 0. So x equals 1 and y equals 0. I'm going to start with the y part, because solving something equal to 0, solving y equals 0 is quite often easier, especially in a factorial form like we've got here. So y is 4 sine squared t minus 7 times the sine of t, and that equals 0. So either 4 sine squared t minus 7 equals 0, or sine t equals 0. I'm going to leave it as an exercise for you to see why that first one can't be true. Now moving on to the second one, sine t equals 0, that means that t must equal 0, or pi, or 2 pi, and so on, some multiple of pi. So let's check that t equals 0 gives us the point that we want. At t equals 0, look at the x equation. X is 1 plus 4 sine squared t times the cos of t. That's equal to 1 plus 4 times 0 squared times 1, which is 1. So this is the point at t equals 0. We get the point xy is 1, 0. So there's it's where we expected it to be. Now we need to show, the question asks us to show that the gradient of this curve is undefined at this point. The gradient dy dx is undefined. So maybe some kind of division by 0. Now we can't find dy dx directly. Y isn't defined in terms of x, but they're both defined in terms of t. So we use our rule that dy dx can be written as dy dt times dt dx. We can't differentiate t with respect to x, but we can differentiate x with respect to t. So dy dx is dy dt divided by dx dt. So now I need to see dx dt and look to see if that equals 0 at this point. So dx dt, here's x down here. It needs differentiating with the product rule, it's got a product in it. We need to differentiate that, which is a little bit messy, and I'm just going to write out what that derivative is. Dx dt is equal to 8 times the sine of t times cos squared t minus the sine of t times the original term 1 plus 4 sine squared t. There it is there. Right. So now I don't need to do any kind of solving with that. I just need to substitute. The key thing here is that I need to find dx dt at x equals at t equals 0. I need to substitute into that to see what's happening when t equals 0. If I put t equals 0 into that, I get 8 times the sine of 0 times cos squared 0, so I get 8 times 0 times 1 squared minus 0 times 1 plus 4 times 0 squared. So all those terms come out to just 0. So the gradient's undefined at this point because I get a division by 0 error. So the denominator is 0, dy dx is undefined. Graphically, looking back at our original function, it's still just as up there at the top. This is because the gradient line is vertical. The tangent to the curve is vertical at that